The anatomy of a muscle tissue consists of being a tube-shaped and separated by three zones, three bands, a thick actin filament, a thin filament, and the cytoplasmic reticulum. The mitochondria surrounds the myofilament, the sarcomere, and the muscle fiber wrap around all those parts, and there are also nuclei surrounding it. A muscle works by your brain sending a signal to the muscle. When the muscle receives the message, the muscle contracts, thus generating force. ATP is used in order to fuel the muscle's contractions. What was found in this experiment was after 0.5 volts, the force created continued to get bigger until it reached 8.5 volts. When it reached 9 volts, the force created was no bigger than the force created from 8.5. These findings are reflected in the table and the graph, where you can see the line overlap, thus creating the same amount of force. All of this was tested with a muscle length of 75 millimeters. In the second experiment, I found that when there is a stimulus rest stimulus pattern, there is 0.59 more force created than if there was just one stimulus. Then the back-to-back stimulus pattern causes even more force than the stimulus rest stimulus pattern, with 0.38 more force created. Subsequently, 4 stimulus back-to-back caused even more than the back-to-back stimulus, causing 0.87 more force. All of these patterns were tested with an 8.5 voltage and a muscle length of 75 millimeters. These findings are also reflected in the table and the graph below. We also found that there was a greater force created by multiple stimuli due to multiple stimuli causing more muscle fiber recruitment. In the graph, the green line is the force stimuli, the blue line is the back-to-back stimuli, and the red line is the stimulus rest stimulus pattern. Experiment 3 tested how the same voltage would react to a stimulus of 30 seconds of 50 stimuli per second and 130. The results were creating a greater peak force, and it was evident that the muscles started to fatigue very quickly after the peak force was reached. The peak force is reflected in the table, and the graph reflects how quickly the amount of force decreases due to the muscle fatigue. The first graph is the trend of 50 stimuli per second. The second graph is the trend of 100 stimuli per second. What I learned during this experiment is that voltage with one stimulus can peak at a certain voltage. After that voltage is passed, the amount of force isn't going to be greater, but will stay the same. But higher force can be created by increasing the stimulus per second. But the higher the stimulus per second is, the quicker the muscle will fatigue.